Hey, what's up you guys? Today's episode 8 of my computer networking series, and today I'm going over BGP and tunneling. So let's get to it. BGP is Border Gateway Protocol, and it's a type of dynamic routing protocol. And before I go any further, I'm going to give you guys a quick routing protocol recap. There's 3 types of routing protocols: static, default, and dynamic. When it comes to dynamic routing protocols, they can be either IGP or EGP. IGP breaks off into several different types, but for EGP, it breaks off into one, and that's BGP. So what is EGP? EGP stands for Exterior Gateway Protocol. That means it's used to exchange information between autonomous systems. Now, what does that mean? Exterior Gateway Protocol manages routes between autonomous systems, and IGP, Interior Gateway Protocol, manages within the autonomous system. So each of these circles is an autonomous system, and EGP routes between these systems, and IGP only routes within the system. An autonomous system is just a network under a single routing policy. It has an autonomous system number, and they're owned by internet service providers. Within the US, there's 30,000 plus, probably 50, 60,000 of them. Without these autonomous systems, the internet would not exist. Here's some more visual representation of an autonomous system. This one's number 1000. It has several networks configured within, configured possibly with OSPF. And then here you'll notice a router, which is meant to configure BGP to another autonomous system's router. So some more about BGP is that it enables efficient, scalable routing across the internet. It connects organizations with their internet service providers. Long story short, we need BGP for the internet. Without BGP, there is no internet. It's a layer 4 protocol because it uses TCP, and it also features policy-based routing, meaning it can allow the admins to either permit or deny certain traffic. Okay, you guys, so now we're in Packet Tracer, and I'm going to show you how to configure BGP. This is our topology. We have this autonomous system here, number 100. We have this autonomous system here, number 200. And this autonomous system is number 300, and we're going to configure it. The IPs have all been set up, the routing has been set up, everything can ping one another. We're just going to configure the BGP aspect. These are the commands we'll be using. This command router BGP autonomous system number is what creates the autonomous system. Then you're going to type in the neighbor with the neighboring IP address with the remote autonomous system number. Then you're going to type in your network address followed by your network subnet mask. So we'll do it one by one. First we go into router 1. I'm going to go into config mode, and I'm going to type in router BGP 100 because we're doing autonomous system 100 to start. So there's router BGP 100. Then you're going to type in neighbor, followed by the neighbor IP address. So for router 1, the neighbor IP is going to be this IP, 50, 50, 50, 50. So we type in 50, 50, 50, 50. Then we type in remote-AS, and we type in the remote autonomous system number, which is going to be 300. So we type in 300, and then we enter. And then we're going to type in our network address, which is going to be 192.168.100.0. Remember, .1 is the default gateway, .0 is the network address. And remember, you want to type in mask. So we have network 192.168.100.0, word mask, 255.255.255.0. And now we've configured this router. Now we'll go into the next router, router 3. For this part, we're doing autonomous system 200. So we do router BGP 200. And on this router, the neighbor IP is 60606061. So we run neighbor 60606061 remote-AS 300. Because 300 is the remote autonomous system number. Enter that. And now we type in the final command, which is the word network, followed by the network address, which is 192.168.200.0, followed by the word mask, and then the subnet, which is 255.255.255.0. And we enter that, and we're done configuring router 3. And now we'll go into router 2. And after this, everything should be set up. Now we're in config mode, and we're going to type in router BGP 300 because now we're creating autonomous system 300. And now for this next command, we'll type in neighbor followed by this neighbor IP address. So the command will be neighbor 50505049 remote-AS 100 because we're connecting to autonomous system 100. We'll enter that. And now you can see we got a notification saying neighbor is up. Now I'm going to repeat this command. I'll just replace this 100 with a 200 to link this network. And I'll replace 50505049 with this IP, 60606062. There it is. Now we click enter, and it shows BGP neighbor 66662 is up. Now to verify, we can type in show IP BGP. This will show if BGP is on the router. We can also type in show IP BGP neighbors. And when you run this, you want to make sure you see established. That's the keyword. Now I'll just copy that, test it on the other routers. Router 1, established, exit. Now do router 3, paste the command, established. Now BGP is configured on this topology, and that is how you do it. The next thing we're going to talk about is tunneling. Tunneling is basically taking one network protocol and wrapping it inside another protocol so you can allow the data to be sent to a network that wouldn't normally support it. The most common usage of this is a VPN, a virtual private network. And this virtual private network acts as a security tool that creates an encrypted tunnel between usually your phone or your computer and a remote server. So here's an example of a tunnel. Normally you would have the data go from each hop to the next hop to the next hop, but with tunneling, the original packet of data is encapsulated inside another packet. So these intermediate routers only see the outer packet, and they forward this outer header to the next route. The original packet is only revealed at the tunnel's endpoint. All right, you guys, now I'm going to show you how to configure a tunnel. What I did here was make a visual representation of what the tunnel would look like. We're going to need 2 new IP addresses for both ends of the tunnel. They need to be in different networks than the networks that are on the original router. So for the end that connects to router 1, we'll use .50.1, and the end that connects to router 3, we'll use .50.2, and they'll be in a /30 network. These are the commands we're going to be using, and now let's go into router 1. So we'll go into config mode, and we'll type in interface tunnel 1 to create the tunnel. Now we're going to type in the IP address, 192.168.50.1, subnet mask 255.255.255.252 because it's a /30, and we'll enter that. Now I'm going to go into router 3 and create the interface for the tunnel on that router. Router 3, config mode, interface tunnel 1. Now for this router, I'll use this IP address 192.168.52.255.255.255.252. Now I'm going to go back into the first router. Now I'm going to type in tunnel source, and the source is going to be the interface that leaves the network and goes towards router 3. So that's going to be this interface, gigabit ethernet 0/1. So the command is tunnel source gigabit ethernet 0/1. Now I'm going to type in tunnel destination, and for tunnel destination, we're going to use the final IP that reaches router 3 from our network. That's going to be this IP. So we'll type in tunnel destination 60.60.60.62 and click enter. And we got a notification saying line protocol change state to up. Now we'll go back to router 3 and we'll configure the source and the destination on this router. They just so happen to use the same source, gigabit ethernet 0/1. So we'll enter that. And this is our tunnel destination 50.50.50.49. And we'll enter that. And it says right there, line protocol change state to up. Now if we want to verify, we can type in show IP interface brief, and it shows right there our tunnel is up. And now we can try pinging 192.168.50.1 from router 3, and that went through. We can also go to router 1 and try to ping the other interface. We already know it works because the first one ping 192.168.50.2, that went through. So in the end, the data is still taking this top route, but the IP being sent is this IP address. It's a great way to mask your IP for security reasons. This is what VPNs are all about, and that is tunneling. And that's a wrap for today, you guys. Thank you for watching my video. I hope you guys learned something new. Today we went over BGP and tunneling. Thanks again, and I'll see you in the next one.